now. Today we're going to cover section 2.3, analyzing graphs of functions. We're going to be looking at the vertical line test. We're going to talk about the zeros of a function. What does it mean for a function to have a zero? Can y'all tell me? What are the zeros? Okay, x-intercepts. I lost my camera already. Hey, follow me, guy. Come on, you can do it. You can do it. Here, boy. Here, boy. Okay. Determine intervals in which functions are increasing. So reading from left to right, increasing means going up. Decreasing means constant means. Okay, hard stuff today. We're going to talk about average rate of change. So if I've got a curve, we're actually going to talk about the average rate of change from one point to another. And we've done this before. Okay, how do you find an average rate of change? What's that called? Slope. That's what it's called. Okay. Yeah. Okay, we've studied functions from algebraic point of view. We're now going to study functions graphically. The graph of a function is a collection of ordered pairs. That's all it is. Remember that x is the directed distance from the y-axis, and y is, which is the same as f of x, is the distance from the x-axis. So the point given on this graph is x units to the right because it's positive there, and y units up. Hard stuff, guys. Remember, dots, open and closed dots are different, right? Closed dot indicates that the point is included. Open dot means the point is not included. Okay, so let's look at this graph right here. Notice this graph is a nice smooth curve. It does not have arrows on the end, which indicates it does not go on forever. On the left side, it terminates at exactly the point -1, 1. Correct? Closed dot. Okay. What about on the right side? Where does it end? The answer to that is you really can't tell me. You know, it ends before 5, 2. Okay, but exactly where? I don't know. Is it 4.999 or is it 4.99999, or is it, you see what I'm saying? So you can't tell me the exact location this graph ends on the right side. That said, what is the domain of this function? What are all possible x values that satisfy this function? Starts at -1. How would you want to do that? A bracket or parenthesis? Can it be -1? Because it can be -1. I'm going to draw the bracket slowly. I'll draw the top part of the bracket and the bottom part of the bracket. Looks like an equal sign, right? Okay, so here's my bracket. I don't draw brackets like that. I was exaggerating on purpose. Okay, so from -1 until I would like to stay with the x values, please, since we're talking about domain, if you don't mind. 5. Okay. Can it be 5? Okay, so parenthesis. All right, so let's talk about the range of this function. What is the lowest point on this function? -3. Can it be -3? What is the highest point on this function? Can it be 3? Okay, so that's domain and range, right? So don't always look at the endpoints. Don't fall into that trap. Just because it starts at -1, 1 and ends at almost 5, 2 does not mean those are the endpoints of both the domain and the range. Okay? Questions on this? Okay. I think I need to scroll down. Yep. By the definition of a function, at most one y value corresponds to a given x. So a graph cannot have more than 2 y values for any x, which means it has to pass the vertical line test to be a function, right? This observation provides a convenient visual test called the vertical line test. So the vertical line test, take that vertical line, slide it around. If it only touches once, then yes, it's a function. Okay. For this particular slide, we've already discussed the domain. What is the value of the function at f of -1? What is f of -1? Looking at the graph. Why is it 1? When the x value is -1, the y value that corresponds to that value is 1. Okay. F of 2. -3. Because when the x value is -3, the corresponding y, I'm sorry, when the x value is 2, the corresponding y value is -3. And we've already discussed the range on this. Any questions so far? We happy to see this level of work for a little bit? Okay. Yeah. Domain is your set of x values. Range are your y values. D comes before x, D comes before r, x comes before y. It's alphabetical. Okay. Next slide is just going to be the answers to those 3 questions that we've already answered. The zeros, you've already told me the zeros are when a graph crosses the x-axis. What is the value of y at the zeros? 0, always, right? Always. To find the x-intercepts, let y equal 0. Okay, not a 0. It's imaginary. Okay. The imaginary numbers would be solutions, but they're not zeros in that case. Okay. Finding zeros. To find a 0, you let f of x or y equal 0. So the first problem here, I want to know the zeros of 3x squared plus x minus 10. It's a quadratic, which means to find the zeros, you're going to have to do factoring. Okay. So if 3x squared minus x, I'm sorry, plus x minus 10 is equal to 0, factor what 2 numbers multiply to get -30. They combine to 1. And you do all the math behind that. Do y'all want me to write that out, the grouping piece of that? AC is -30. I need a product, excuse me, of -30 that combine to what number? 1. What are those 2 numbers? 6 and -5. Which means I could write this as 3x squared plus 6x minus 5x minus 10 equals 0. What does this first pair have in common? X, 3x. First pair has a 3x in common. So if I factor out that 3x, what's left? X plus 2. What does the second pair have in common? 5, but because it's a -5x, my leading term, I'm going to factor out a -5. So taking a -5 out, I'm left with x plus 2. What do those 2 terms have in common? Take out the x plus 2, what's left? Just like this, right? So now it's factored, it equals 0. set each of those to equal 0. So 3x minus 5 equals 0. So you add 5 to both sides and then divide by 3. Gives you x equals 5/3. And on the next one, that x2 equals 0. Subtract 2 from both sides, you get x equals -2. So the zeros of A are x equals small to large, -2, comma, 5/3. Part B, how would you go about finding the zeros of that one? Make this a 0? Okay. Do I? No, we were doing another section. This is 2, 3. You said square both sides? Okay, so squaring both sides gives me 0 equals 10 minus x squared. Next step, 10 minus x squared. There's a minus there. I would rather add x squared, if that's okay. Okay. So I now have x squared equals 10. Next step, square root of both sides. What is the square root of x squared? What is the square root of 10? Close. No. Plus or minus square root of 10. Okay. Why plus or minus? Well, because we're squaring it. Okay. If I went inside here and put in, if x was positive square root of 10, what happens when you square positive square root of 10? You get, if you square the positive square root of 10, you get 10. And 10 minus 10 is 0. What happens when you square negative square root of 10? You still get 10 because it's a negative times a negative. Negative times a negative is a positive, right? So I get 10 minus 10 again, which is 0. So the answer to part B is plus or minus 10, the square root of 10. Part C, how do I find the zeros? Not t, h of t. Okay, set y to 0. So 0 equals 2t minus 3 over t plus 5. Let me ask you this. Can the bottom ever be 0? Why not? That's illegal, right? So, because it's undefined. So since the bottom can't be 0, how can this function or whatever be 0? Top has to, can the top be 0? Yes. Okay, so 2t minus 3 equals 0. How do I solve that? Okay, add 3 to both sides, divide by 2. There you go. Questions on those? All right. Is the rest of the solution to part A. And they actually drew a picture of it so you can see what it would look like. Yes, no problem. Oops. Back down here, in case anybody wants a screenshot of that. Next slide is going to be part B. There's part B. Worked out. They drew a picture. So that graph is actually a semicircle. Part C. I'm going to point out the way they talked about doing it. When you set it equal to 0, you have a fraction on one side, right? What happens if I multiply both sides by t plus 5? The t plus 5 on the left side cancels. And on the other side, I have t plus 5 times 0. Okay, so they just did that. And that's basically what I did. I just kind of talked about the fact that t plus 5 can't be 0. And notice they didn't call it the x-intercepts, did they? There's no x in the problem. It's a t-intercept. And this is the graph of that last part. Okay. Talking about when a function is increasing and decreasing. I think we've done that this year, haven't we? Have we talked about intervals when the function's increasing, decreasing, or constant? Okay. So looking at this graph, as we move from -2 to 0, and when we're talking about increasing or decreasing or constant, we always talk about moving left to right. As we go from -2 to 1, the graph is going down, therefore it's decreasing. As we go from 0 to 2, the graph's not going up or down, so it's constant. From 2 to 4, the graph is going up, so we call it increasing. So again, when you're talking about increasing and decreasing functions, we're only talking about going left to right. Don't go backwards on me, okay? Y'all okay today? It's like a bunch of zombies or whatever in here. We're dead. No buffet this morning. That's during spring break. That's great. Okay. Well, I mean, you know, before spring break will be the last time you see me in my 40s. When you get back from spring break, I turned 50 the day before. Black roses back from spring break. Love you guys. Okay, a function is increasing on an interval if for any x sub 1 and x sub 2, x sub 1 is less than x sub 2. To me, this kind of starts getting confusing. Okay, what it is saying is if it's increasing, if this is x1 and this is x2, it's probably going up from those 2 points, right? So the value of f of x sub 1 has to be less than f of x sub 2. If it's decreasing, the opposite happens. And if they're constant, obviously, the two values have to be the same. Information like this is what makes algebra confusing to some people. To help you decide whether a function is increasing, decreasing, or constant, you can evaluate the function for several values of x. However, you need calculus to determine for certain all intervals on which a function is increasing, decreasing, or constant. And this is actually talked about in calculus. Because they're equal, right? Yeah. The points at which a function changes its increasing or decreasing constant behavior are helpful when determining the relative minimum or the relative maximum. And we've talked about maxes and mins with quadratics, right? Okay. Well, a quadratic opening up, how many minimums does it have? 1. How many maximums does it have? None, because it goes up forever. A quadratic opening down, how many maximums does it have? 1. How many minimums does it have? Okay. So what we're going to talk about now are called relative minimums and relative maximums. We're also going to talk about absolute. Okay. Lots of words on here. I'm moving on. So here is a graph. And let's assume, now let's not assume anything right now. So looking at this graph, I don't know what it does. You know, it doesn't have an endpoint. It doesn't have an arrow. So I really don't know what this graph is doing after these points. So I'm going to ignore them. Okay. So this graph going from left to right, it's going down and then it's going up. As soon as it changes directions, all the points close to this point are higher than it is, right? So because all of these points are closer and all these points are higher, this is called a relative minima. It's actually saying minima because that is the plural of minimum. Okay. So this graph has two relative minima. This is a relative minimum. This is another relative minimum. These are relative minima. Got it? This is a relative maximum. This is another relative maximum. Together we have two relative maxima. So it's the same concept as the parabolas, except we're using the term relative. Okay. Next page. We'll study a technique for finding the exact point at which the second degree polynomial function has a relative minimum or relative maximum. For the time being, we're just going to use the calculator to find an approximation. We're going to use the calculator. Okay. Here are three graphs. We're going to talk about increasing, decreasing, constant behavior. So let's look at A. And let's assume arrows on this one. We'll just put arrows on all of them. Okay. Graph A. When is graph A increasing? You say in quadrant one, you say everywhere. Always. Reading from left to right, this graph is always increasing. Reading from left to right, is this graph going up? Is it still going up? Is it still going up? Even though it slows way down, it's still going up, right? So when is this graph increasing? It's increasing on the interval from negative infinity to infinity. When is this graph decreasing? Well, if it's always increasing, can it? When is this graph constant? Never. Okay. All right. Part B. When is part B? When is that graph increasing? So you're saying it stopped at -2? I put arrows on there. Not -1, 2. When we're talking about when is a function increasing, all I care about is the domain. So it's increasing from negative infinity to -1. Is that a parenthesis or a bracket? Okay, it's a parenthesis. Because here in a second, you're about to tell me that it's doing something else from -1 to something else. And you can't tell me it's both increasing and decreasing at the exact same time. Makes no sense. Okay. So it's increasing somewhere else. 1 to infinity. Okay. We're only talking about the domain. On what interval is the function increasing or decreasing or constant? We're talking about the values of the domain. Is this function ever constant? No. Is it ever decreasing? Okay. When is this function decreasing? From -1 to 1. Are you doing all right? Okay. Part C, when is this function increasing? From -infinity to 0. Where is it decreasing? Decreasing on the interval 2 to infinity. And constant. Any questions, comments, anything here? Pretty good. Okay. Here's the book answers. Okay. Average rate of change. So I've got a graph. It's a curvy graph, and I want to know the average rate of change over a certain interval. Notice on this particular graph, to get from the first point to the second point, it was increasing for a while, and then it was decreasing, right? But all they want to know is what is the average rate of change from this point to this point. Drawing a line that goes through a curve twice like this, it's called a secant line. So we are finding the slope of the secant line. The slope of the secant line gives us the average change or the slope. Okay. A line through the 2 points, like I just said, is called the secant line. The slope is denoted as m sub sec. So m is used to represent slope, right? Y equals mx plus b, m is slope. So when you see m with a subscript of SEC, that stands for secant. It's not just, that's not seconds, you know, it specifically means secant. The slope of the secant line. Does this formula look familiar? Okay. The way we've seen it in the past, though, is like this. But they're the same, right? Does it matter which point you call point 1, point 2? No. It does matter that you're consistent, though, right? Okay. Find the average rate of change of f of x equals x cubed minus 3x. Letter A, I want to know the average rate of change from an x sub 1 is -2, x sub 2 is -1. So we're looking for the slope of this secant line. Since they chose x sub 2 to be -1, we're going to have on the bottom -2. No, that's a -1. X sub 2 minus x sub 1. And what is the corresponding y value that went with x sub 2? What is the y value that goes with -1? 2. Minus the y value that went with x sub 1. -2, -2. Okay. Simplify that. 2 minus -2 is 4 over 1 minus -2. 1, which is 4. Does it make sense that the slope of this line is 4? A very steep line going up, 4 makes sense, right? Make sure you ask yourself that question. If you've got a line going up and you tell me the slope is negative, I guarantee it's wrong. Okay, without even looking at the problem. Part B. What do you mean? I've got to use these values. It tells me to use those values. So I've got to use the corresponding y's to go with those. Okay. So the bottom is x of 2 minus x of 1. That gives me 1 minus 0. On the top, what is the y value that goes with an x value of 1? Okay. 1, negative 2. Minus, what is the y value that goes with the 0? 0, 0. Gives me a negative 2 over 1, which is negative 2. Does that make sense? Yes, no? Okay. Does that line look not as steep as the first line? Okay. Is that line going down, giving us a negative slope? Yeah, okay. So there's their first one. And there's their second one. Okay, so that is it for 2-3. Okay, that's all of 2-3. I'm going to go back and pick up some practice problems since we have a little bit of time left. So these are some of the practice. Didn't we work? I think we worked the first 2 on this one, didn't we? Or do y'all remember? Okay, so is 1 a function? No, because it's a circle. Number 2, how do you find the domain of that? Or no, is it an equation? Okay, is it a function? Yes. You give me any x value, I can only give you one y that goes with it. So it's a function. Number 3. This class did these. Let me go on to the next problem. All right, number 4. I think we did it as well. How do you find the domain of number 4? Do you see any problems with it? You can't do what? You can't divide by 0. In this case, I'm dividing twice, right? So I know that this guy right here can't be 0. And I know that this guy right here can't be 0, correct? I'm talking about the denominator as a whole. That denominator can't be 0. That denominator can't be 0. Which means I have x can't be 0. I have x plus 5 can't be 0. Can you do anything with x can't be 0? Can you simplify that? No. X plus 5 can't be 0. Can you simplify that? X can't be? Okay. So the domain of this function would be all real numbers except 0 and negative 5. Pay attention to how the questions are read. Read the words. It might say all real numbers except x equals 0 and x equals negative 5. So it's throwing those 2 out, even though it said equals, because it said except, it's throwing them out. I saw that with the problem Matthew was doing earlier today. Yeah. Okay. Number 5, Do you see any problems? Be very general right now. Just be general. Don't give me any numbers. What? Okay, the bottom can't be 0. So I'm going to circle this whole thing right here. And I'm going to say that right there cannot be 0. Any other problems? Okay, this piece right here that's inside a radical, I'm sorry, I just covered it up. This must be greater than or equal to 0. Whatever is inside the radical must be greater than or equal to 0. So 6 minus x is greater than or equal to 0. If I added x to both sides, I could say that 6 is greater than or equal to x. I don't like writing it that way. Let's pick up the whole thing and flip it over. X must be less than or equal to 6. However, change colors. 6 minus x can't be 0. Add x to both sides. 6 can't be x. X can't be. Okay, well, hold on it. Over here, x has to be less than or equal to 6, but over here, x can't be 6. X is less than 6. Okay. A problem I might get some numbers wrong here. A problem I was working on with Matthew earlier said something along the lines of x is greater than 0. X can't be 5. How do you make that happy? Can it be 6? Can it be 4.999? Can it be 5.001? Can it be 5? Okay, so I could say in words, x is any number greater than 0 except 5. If you wrote it in interval notation, it would look like this: 0, comma, 5, union, 5, comma, infinity, right? All parentheses, because there's no equal sign in there. 4, okay. Y'all good with the difference quotient? We worked that in class. How about that? This is one I was working, something like the one I was working with Molly earlier. To complete the square on this, you actually have to make this a 1, which means for this problem, you have to factor out a 7. Can you factor a 7 out of a -1? And the answer is yes. The way to think about this when you're doing it, okay? Because I've got to make that into a 1. How do you turn a 7 into a 1? Divide it by 7. So if I take that 7 out, I'm asking myself, okay, 7 divided by 7 is -1 divided by 7 is -1/7. If I was to multiply 7 times -1/7, I would in fact get -1. To complete the square, I'm going to have to add something. But because I add something, I have to subtract something. And here's my +1. What is I'm completing a square on this, folks. What is my b? -1/7. What is half of that? What is that squared? It's 196th. Because 14 times 14 is 196, which means I have to add 1 over 196 and I subtract 1 over 196. Yes, it's ugly, but it is what it is. When doing this, the neat thing about it is this piece factors into, this guy is so important. It's x minus 1 over 14 squared minus 7 times 1 over 196. Plus 1, and then y'all can finish it from there. Okay. 2, 2, 3, 1, 2, 3 are due. Guys, I'm not going to enter grades probably on Monday morning. I'll be doing other stuff. So technically, I guess you've got till Monday midnight. Okay.